Hello, welcome back. We're going to take a look at the 2017 free response calculus exam for the BC test. And we're going to start off with question number one. Question number one is a calculator question. So again, I'm going to do the calculator. I've already done the calculator work ahead of time, so you can stop the video if you need to and check the computations if you need. Okay, so question number one talks about a tank of a height 10 feet. And it has an area of horizontal cross-section. Now, it says horizontal cross-section. To me, that sounds like I'm going to look for volume there, so I'll pay attention to that later on. And the horizontal cross-sections are given by the function a, where a of h is measured in square feet. So that's what they're giving you right here, the area of each cross-section. The function a is continuous and decreases as h increases. Selected values for a of h are given in the table above. So for question number A, for part A, it asks, use a left Riemann sum. Now we all know Riemann loves rectangles, so we're going to be doing some rectangles on this question right here. So let's go ahead and get started. Let me move down here. It says use a left Riemann sum of 3 subintervals indicated by the table, the data above, to approximate the volume of the tank. Now I'm looking for volume of the tank, so make sure you get the correct unit. As a matter of fact, it's even telling us that. So I'm going to go ahead and start here. So I'm going to draw my rectangles, even though you think this is crazy, I say go ahead and do it. Draw your rectangles. Get the answer right. So we're looking at a left Riemann sum, so between 0 and 2. We're looking at the left side, so we're going to pick the 50.3. So we're going to go, this is going to have a height of 50.3. So there's my first rectangle. And then between 2 and 5, we're going to pick the 14.4. Wow, that dropped off very quickly. Not drawn the scale, my favorite mathematical phrase. In between 5 and 10, we pick the one on the left, which is a 6.5. So again, not drawn the scale. So we're looking for the area, obviously. So I'm going to go ahead and set this up as a Riemann sum using an integral. Between 0 and 10, we're going to say that the volume between 0 and 10 is a of h dh. Write it out this way. We're saying that the volume is the area under an interval, which we already know. Now we're using a Riemann sum, so we're actually approximating it. And so for our first rectangle, it's going to be 2 wide by 50.3 high, plus the second rectangle is 3 wide by 14.4 units high, plus, and the last one is 5 units wide, and it has a height of 6.5. And again, you can use your calculator. You can type all of this in your calculator, and you're going to get 176.3 cubic feet right there. And that would be your answer. So let's talk about how the AP will score this question. All right, so you're going to get basically for all of this work right here +1, and then +1 for your final answer. You can leave your answer unsimplified if you want to. AP is okay with that too. So this is basically 2 points. You actually do get 1 point for the units, but you have all the units in all the right parts, A, B, and C. So that's basically like 3 points right there. All right, so let's go ahead and take a look at question B. Now, question B, we went all the way down here. Let me extend the page. Question B says, is our answer, does our approximation of part A overestimate or underestimate the volume of the tank? Well, we know we are taking a left Riemann sum, and we are told that the values are decreasing over time. Well, what does that tell us? Well, if I were to draw something, and you can kind of take a look here, if I were to draw something, a decreasing function, and I took a left Riemann sum every time, oops, a left Riemann sum, sorry about that, I messed up there. We go over every time. If we take a left Riemann sum, we're going to be a little bit over, so this will be an overestimate. Sorry, I had to think about that for a second. This is an overestimate, and that's true. You'll have to think about these for quite a bit. So this is an overestimate, and that's just because this is a left Riemann sum, and the values are decreasing. So it's important to think about it. Slow it down. Like I said, I had to draw it, and I realized I drew mine wrong, and that's okay. That happens. Okay, so let's go and take a look at part C here real fast. So that's part A and B right there. Let's take a look at question C right here. Let me go scroll up here real quick. Let's go take a look at part C. Next page. Part C says the area in square feet of the horizontal cross sections. Up there, it is horizontal cross sections, and they're giving us areas here. We got horizontal cross sections of height h is given by this. So this is the actual areas. See, for part A, they gave us approximations, and here they're giving us the actual horizontal cross sections. Based on this model, find the volume of the actual tank. So this is just like what we did before. We're looking for the volume. Well, if I'm looking for the volume, if this is my cross section, so if I have like if I have a cross section right here, and the area here is given by f of h, well, we know that the width is dh. So I can find my volume by taking my area times my height, or the depth of it, area times. So to get the volume, we're going to take that f of h times the height, which is dh, because it's really tiny thin, and then we're going to integrate that from, let's see here, from 0 to 10. So our volume would equal the integral from 0 to 10 of 50.3 over e to the 0.2h plus h dh. And just type that in your calculator. And again, I've already done this for you. And you get 101.325. Now you actually get 338 as well, but remember the AP only wants it to the first 3 decimal places. You can have more, you can have that, they just won't grade it, okay? So it's okay to have more, just don't have less. And then get the units, this is going to be, again, cubic feet. So you're going to get 1 point for the integral here on the AP and 1 point for your answer. So that's worth a whopping 2 points. By the way, I forgot to mention part B was worth only 1 point. Okay, so, all right. And there's our work there for part C. Pretty easy to do. All right, so for part D now says water is being pumped into the tank. When the height of the water is 5 feet, oh man, right away I'm thinking water being pumped and water height. I'm thinking related rates here. That's what I'm thinking. I'm thinking of related rates. And they had one this on the 2016. They had this on the 2017. Chances are you're going to see it again. The height is increasing at a rate of 0.26 feet per minute. So they're telling me the change in height is 0.26 feet per minute. Using the model from C, find the rate at which the volume of water is changing. So they're asking us to find dV dt when the height of the water is 5 feet. Indicate units of measure. So indicate the correct units. So let's see here. Well, we know to get the volume, we have this integral right here. To get the volume, we have our integral. And it was f, now I'm going to use a different variable, f of x dx from 0 to h. Okay, so that's my volume. I want to find out how fast the volume is changing. So if this is my volume formula right here, now remember I use x and x. We used to use t and t. You can even use h, and that's okay. So there's my volume formula to get. So if I want to calculate the rate of change of volume, I need dV dt. Well, this is a tricky part. We're going to use our second FTC right here. So when I take the derivative of an integral, all we're doing is replacing each of these x's with h. So that's just going to become f of h dh. And of course, that's going to be dh dt when we take that derivative. So, ready? So we get dv dt from part C. We know f of h is 50.3 over e to the 0.2h plus h dh dt. And now we're just going to plug in our values. Just plug them in. So dv dt would equal 50.3 over e. Now h is 5, right? So that just becomes e to the 1 plus 5. dh dt, they're telling me is 0.26. And if you type that in your calculator, which I already did for you, you're going to get 1.694, and you still get this 419. But this is all we will need, the first four, the first three decimal places afterwards. So our answer, we would say, when h is 4, or sorry, when h is 5, the volume is increasing at a rate of 1.694. Let's get the units. Volume is changing by cubic feet. Time is being measured in minutes. And that's your answer right there. Oh, don't box in your answer, so let me go ahead and erase that. Never box in your answer. Remember we talked about that, right? We don't box in. All right, don't box in your answer, okay? All right, and let's see how many points this would be worth right here. Let's see. To get the derivative, just this right here, that'd be worth plus 2 points right there. And then your answer was worth plus 1 point. So that'd be like 3 points right here for this question. That's a hard question. Go back and try that one again. I would definitely want to do part C and part D for the AP exam for this year. Okay, all right. So join us in the next video for question number 2. And I'll see you there, okay?